Section 4.5, Example 4 on page 266, we have when a linear inequality is solved for y, the direction of the inequality symbol determines which side of the boundary line to shade. If the symbol is less than or equal to, shade below the boundary line. If the symbol is greater than or equal to, shade above it. Sometimes you must first solve an inequality for y before using the method described above to determine where to shade. Example 4 says an interior decorator is going to remodel a kitchen. The wall above the stove and the counter is going to be redone as shown. The owners can spend $420 or less. Write a linear inequality and graph the solution. What are three possible prices for the wallpaper and tiles? Notice that the tiled area is 3 feet by 4 feet or 12 feet squared. The papered area is 3 feet by 8 feet or 24 feet squared. We can start by letting x be the cost per square foot of the paper and let y be the cost per square foot of the tiles. Since there will be 24 square feet of paper, we have 24x, and there are 12 square feet of tile, so we have 12y. 24x represents the cost of the papered area, and 12y represents the cost of the tiled area. If we add these two together, the total must be $420 or less, so we'll use less than or equal to as our inequality symbol. As the previous slide states, it is easy to decide whether we are going to shade above or below our boundary line if we have our inequality with y by itself. So we are going to get y all by itself. To do this, we can subtract 24x from both sides. 24x minus 24x is 0. We can bring down our 12y. We will keep our inequality symbol less than or equal to since all we did was subtract. 420 minus 24x can be written as negative 24x plus 420. Now to get y by itself, instead of 12 times y, we can divide everything by 12 to undo the multiplication. 12 divided by 12 gives us 1, so we're left with 1y, or just y. Negative 24x divided by 12 gives us negative 2x, and 420 divided by 12 gives us 35. We again are going to keep our inequality symbol as less than or equal to because we divided by a positive number. So we divided by positive 12, even though we had some negatives involved, the number we actually divided by was positive 12. As a reminder, if you divide by a negative number or multiply both sides by a negative number, you do have to flip your inequality symbol. In this case, we get to keep it the same. In order to know how to graph our boundary line, we're going to start by changing our inequality to an equal sign. So we have y equals negative 2x plus 35. Now we're going to identify our slope, which is negative 2, or negative 2 over 1, and our y-intercept, which here is 35. We can start by graphing our y-intercept, so we'll start at 35 on the y-axis, and then using our slope of negative 2 over 1, we could go down by 2 and then to the right by 1, but notice to get to 35, I had to count by 5s on my y-axis, so going down by 2 would be a little bit tricky. So instead, I can multiply the top and bottom by 5 to get negative 10 over 5. This still equals negative 2, so instead I can drop down 2 blocks, which gives me negative 10, and move over 5. Here I did count by 2s, so that means I have to go over 2.5 boxes, but a half is a little bit easier than trying to find 2 out of 5. So we can continue this pattern to get some extra points to create our boundary line. Now because our inequality had less than or equal to, we are going to use a solid line. So I'll connect all my dots with a solid line. Again, because we have less than or equal to, we are going to shade below our boundary line, which would be this area right here. To identify 3 possible prices for the paper and tiles, I have chosen 3 points within the shaded region or on the line since we have a solid line because of our less than or equal to. And over here we have the point 2.5, meaning we can spend $2 per square foot on paper and $5 per square foot on tile. Or we can have the point 15.5 over here, which lands on our line, meaning $15 for paper, $5 for tile, or this point right here, which was 5.20, $5 for paper and $20 for tile. The work for this problem is written out on the next few slides. And now I would like you to try number 8 on page 267. A fish market charges $9 per pound for cod and $12 per pound for flounder. Let x equal the number of pounds of cod and y equal the number of pounds of flounder. What is an inequality that shows how much of each type of fish the store must sell today to reach a daily quota of at least $120? Graph the inequality. What are 3 possible amounts of each fish that would satisfy the quota?